Good morning students. Today we will do a very important topic, that is Kmap or karnaughmap. If you want to minimize any binary expression in digital electronics, then it is very important to learn Kmap. Now before learning Kmap, we will see two things. One is POS, that is product of sum, and SOP, that is sum of product. Now what is product of sum? See, this is a function of three variables A, B and C. Now if I write A plus B dot A plus C, you can see that first we are doing sum of two variables. Here A and B, we are making sum of A and B. Here A and C, we are making sum of A and C. Then we are making product of these two sums. So this type of equations are called product of sum. Another one is sum of product or SOP. In case of SOP, see, this is an example of SOP by using three variables A, B and C. Now what is the SOP form? First we will, that is SOP means sum of products. So plus we will make products, then we will make sum of all those products. In this case we are making product of A and B and A and C. Then we are making sum of these two products. These two are the product form. Then we are making sum of these two product forms. So this type of equations are called SOP or sum of products. Now we will do Kmaps of 2 variable, 3 variable and 4 variable. First we will do Kmap for 2 variable. Suppose an equation is there, function of A comma B is equal to summation of mean term 0, 2. Then what does it mean? This means that these two boxes 0 and 2 will have 1 and all other boxes will have 0. Now what is the concept of box in Kmap? If number of variables are 2, then the Kmap will have 2 to the power of 2, that is 4 boxes. So if number of variable is n is number of variables, then number of boxes of Kmap will be 2 to the power of n. So in case of 2 variable expression, the number of boxes of Kmap will be 2 to the power 2. If n is 2, then number of boxes will be 2 to the power of 2, that is equal to 4. Now how to draw Kmap and how to give numbers in the boxes, how to put numbers in the boxes. This is the Kmap of our 2 variable expression. See, there should be, for 2 variable expression, there should be 4 boxes. So these are the 4 boxes, 1, 2, 3, 4. Now one variable is A, another variable is B. We will put one variable in rows and another variable in columns. In this case, we are putting variable A in rows. That means the first row will be indicated by A complement. The second row will be indicated by A. Now when it comes to columns, the first column will be indicated by B complement and the second column will be indicated by B. So what is the first box? A complement means 0. The universal convention is A is 1, the variable in its true form is 1 and in its complemented form is 0. So A bar represents 0, A represents 1. Similarly here B bar represents 0 and B represents 1. So what is the number notation for the first box? the first box will be 0 from rows, 0 from columns. So 0 0. 0 0 means 0. In binary 0 0 means 0. Now the second box, 0 from row, 1 from column. So 0 1. In binary notation 0 1 means 1. This box 1 0. 1 from rows, 0 from column. So 1 0. In binary notation 1 0 means 2. This box 1 1. 1 from row and 1 from column. So 1 1. In binary notation 1 1 means 3. So these are our box numbers. Now I am removing this. This is for your understanding only. Now see, in this expression, what are the boxes? Those are mentioned over here, 0 and 2. So these boxes, those box numbers are mentioned in mean term expression. This is called mean term expression. Those boxes will have 1. So 0 and 2 will have 1. Rest all other boxes will have 0. So this is our variable. We put our values in respective boxes according to variables. Now the next important things in case of Kmap is grouping. You need to group maximum possible number of ones. But while you are making groups, you need to keep in your mind certain important things. One is number of one. The first rule of grouping is number of ones should be even. Even number of ones. Rule number 2 is even number of 1 means 2, 4. Not only even, number of 1 should be in power of 2. Not only even, in power of 2. Power of 2. So, what are the number of ones that can be put in a group? 2, 4, 8. They must be even, at the same time they must be in power of 2. That means 2 to the power of 1, that is 2, 2 to the power of 2, that is 4, 2 to the power of 3, that is 8, 2 to the power of 4, that is 16. So, you can group 2 ones, 4 ones, 8 ones, 16 ones like that. Okay, and maximum possible number of ones should be in a group, keeping the rules maintained. So the first is number of ones should be in power of 2. The second is there should be consecutive placing of ones. That means there should not be any gap. And consecutive placing means they should be in continuous orientation, either horizontally or vertically, not diagonally. That means either in this manner or in this manner, not in this manner. If a single one is over there, another one is over there, you cannot group these two ones. Only horizontal or vertical ones, those are put in consecutive boxes without any gap, can be put in a single group. In this case, see, these two ones are following all the rules. 2 ones are in consecutive 2 vertical places. So we can make group of these 2 ones. Now the next step is we need to find out expression for this group. Now what is the expression for this group? The expression for this group is, see, what is common for both of these 2 ones? What is common? You see that row wise nothing is common. This one is represented by A bar. This one is represented by A. So row wise nothing is common. But column wise you you can see that this one is represented by B bar. This one is also represented by B bar. So, what should be the common expression for these two ones? That is, for this particular group of ones, that is y equal to B bar. So, these are the basic steps of minimizing an expression, a boolean expression by using Kmaps. So, what are the steps? First, you need to plot the ones in the Kmap. Then, you need to make group of ones, and while you are making group of ones, you must keep in your mind certain possible things, that is rule of grouping. What are the rule of grouping? Number one is number of ones in a group should be in power of 2, and rule number 2 is the ones should be in consecutive places either horizontally or vertically, not in diagonal manner. So, while you have made group of ones, the next is you need to find out expression for each individual groups. In this case, there is only a single group of ones. So, we are making expression for this particular group, and that is the minimized expression for this minterm. Now, you can ask me, what is the expression of this minterm expression? What is the variable expression for this minterm expression before minimization? What is the original expression before minimization, and how to do this? This is very simple. The same thing, you put the Kmap, you do the Kmap A, B, A bar, A, B bar, B. Now what are the boxes? 0, 1, 2, 3. Now what are the boxes? Those are mentioned 0 and 2. So before minimization, how to find out the expression? Before minimization, the expression can be found out by taking expression for each individual one without making any group. So what is the expression before minimization? That is A bar B bar. For this one, see, this one is sharing A bar from row, B bar from column. So what is the expression for this particular one? A bar B bar. And for this particular one, what is the expression? A B bar. So what is the overall expression? For this minterm expression, what is the overall expression in terms of variables? That is expression for this one, that is A bar B bar, plus, why plus? Because this is minterm form. Minterm form will always give you expression in sum of product form. And what is the expression for this one? That is A B bar. So A from row, B bar from column. So this is the expression before minimization. Okay? And this is the expression after minimization. Right? By using Kmap. Okay? So using Boolean expression also you can cross check whether your minimization using Kmap is correct or not. How? You take B bar common. So this is A bar plus A. A bar plus A is equal to 1 according to Boolean algebraic rule. So B bar dot 1. B bar dot 1 is equal to B bar according to Boolean algebra. So B bar. See, we are having same expression from Kmap minimization and from Boolean expression minimization. So these are the very basics of Kmap. And one thing is very important, while you are putting box numbers, keep one thing in mind, that is which one is your MSB and which one is your LSB, because accordingly the box number will change. How the box number will change? See, A is our MSB for this particular example. That is why we are writing like A bar B bar. A we are putting first in the left side. So A is our MSB. We are putting our MSB in rows, right? And these are our box numbers coming. Now with a simple example, I will show you if I put MSB in column, then how it will change. See, suppose if I put MSB in column, then how it will change? Suppose I am putting my MSB A in column here and LSB B in rows, right? So how it will change? See, the first column will be A bar, second column will be A, that means 0 and 1. The first row will be B bar, second row will be B, that means 0 and 1. See, what is the first box now? The first box is 0. First you need to take the MSB. So this one is your MSB. So this 0, then this 0. Next, see, 1 for MSB. First, left side you need to put the value for the MSB. Then 0. This one is, see, 0, 1. This one is 1, 1. Right? So see, what are the box numbers? 0, 0 means 0 in binary. 1, 0. 1, 0 means what? 2. 0, 1 means 1. 1, 1 means 3. So 0, 1, 2, 3. Right? This is how your box numbers have changed. While you are putting MSB in columns and while we are putting MSB in rows, then this is our box number 0, 1, 2, 3. Right? So both are equally right. You can choose any one of these two practice, but practice any one out of these two to make it easy to crack in your exam. Now these are the very basics of Kmaps. For 2 variable only we have studied now. In next class we will study 3 variable and 4 variable Kmap as well. Thank you. And one thing is a very humble request to all of you. Please subscribe the channel so that you can get all the contents I will gradually be uploading. Thank you, and watch the videos seriously so that you can do well in your exam. Okay, thank you so much.